All right, guys. So in this module number 8, where we are going to cover the resource management and monitoring. So when we say resource management and monitoring, the overall resources have been provided to your virtual machine from your ESXi host. How we do the resource allocation, how we do the resource optimization in case of somewhere you feel the resource congestion, okay, and how you will measure the performance of the resources being utilized in your environment. It could be your CPU, memory, storage, network sometime, okay. So under this module, we are going to talk about the different lessons. So those lessons are first to identify the vCPU and virtual memory concept, how these being shared among the virtual machine, then controlling the resource allocation, resource monitoring tools, monitoring resource uses, and using the alarms. So these are the 5 lessons we are going to cover under this module. Okay. So when we say virtual CPU and memory concept, so we have to understand how the CPU rationalize and how these are being shared to the virtual machines from different hosts, what all layers comes in between, and recognize the technology of memory reclamation, identify additional technology that will improve the memory uses, describe how virtual SMP, symmetric multiple processing works, when my one CPU can be shared among multiple machines, explain the VM kernel using the hyperthreading as well. All right, so when we say the basics of memory virtualization, so end of the day, my host have the physical memory. Out of that physical memory, that host, so this is my total physical memory. Out of this, ESXi is going to use some of the memory that is being reserved for your hypervisor, and on the top of it, it will just starting giving the memory to your virtual machine. So for example, out of this 8 GB memory have been allocated to this virtual machine. So how this virtual machine consuming the memory have been allocated. So some of the memory which will be you can see here, guest OS, physical memory, whatever the amount of memory have been given to the guest. Out of this physical memory, guest means your operating system, your virtual machine when you are using. So how it's consuming in different way. Probably you could see the blue line, the green line, the orange line. So these are the different running processors. Just for example, not only 3, it could be 4, 5, 6, any number. This is just an example. So whatever inside the operating system running applications, so running applications identify my operating systems only. Okay. So this is the memory have been assigned. So whatever application require the memory, so they will call as a parent to its virtual machine where my operating system is running. Okay. Then again, this 8 GB is considered by this application as a physical memory, but actually it is not physical memory. The end of the day, this consumption is happening from this ESXi host. Okay, this is my physical ESXi host. End of the day, memory is going to the physical host from the physical memory bank that is available to my ESXi host. All right. So same way, if we have another VM that will follow the same structure and same architecture. So guest memory is presented to application by the operating system. Guest OS physical memory, the presented memory by your virtual machine by the ESXi VM kernel. So there is always ESXi has a VM kernel layer. Host machine memory that is managed by virtual machine provide continuous accessibility of memory is used by the virtual machine. So that's all being taken care by your ESXi host. And under this, if you remember, I told you, always there is a soft layer that we called as virtual machine monitoring. So this virtual machine monitoring layer is a layer between your ESXi VM kernel and your virtual machine, and it identify what is the requirement and what is the cap. However, it will not go beyond 8 GB from the provision one, but maybe at a time, if it's require more than 8 GB, that's also we have some possibilities. Like sometime the consumption go more than 8 GB. So how ESXi will manage them, and how will ESXi manage the memory reclamation or overcommitment? ESXi use the different technologies for that. So here is the VM, the example what I was telling you, memory overcommitment. So when we say overcommitment, so now you can see my host machine memory is 32 GB. Right away, we have configured the like 8, 8, 8, 8, 32 GB. But at the moment, virtual machine required more than totally 32 GB. Like for example, 2 GB extra here, 2 GB extra here, 2 GB extra here, 2 GB extra here. So in that case, what it will do, what my hypervisor will do, my hypervisor will change the non-accessible or non-active content in a swap file and store the memory pages in a form in underlying data store in a form of the swap file. So these are the swap file. So when swap file will get created and how much is the size? So there is no fixed size because swap is dynamic. Like for example, now in this situation, my host having crunch of 8 GB memory. So what it will do, 8 GB means 2 GB from here to here to here to here. So the inactive 2 GB pages, when I say inactive 2 GB pages, those are most currently in use, but yeah, somewhere some application is consuming. So it will send this 2 GB inactive page in the form of swap file. So this swap file will get created under the data store, under the ESXi host shared data store. So it could be your SAN data store again, it could be your vSAN, it could be your NAS. So it can be defined. So where you want to define this data store, when you will see, when we will migrate the VMs and all, by default, these swap files being created by default location is where my VM folder is allocated. Okay, to get and faster access. Okay, but yes, it can be defined. My swap file can be created on another place also. When I say another place, simply if I take one example, this is my ESXi host, and this have, just assume this have one data store. This also have another shared data store, but this also have a local data store. So this is my shared data store 1. This is my shared data store 2, and this is the local data store. So whenever it comes to come, where VM swap file will get created, swap will only increase its space. It's a dynamic one whenever it is required. Like for this example, my host is crunching 8 GB of memory. So in this case, any of the VM, whenever it requires swap, so again, it's defined. It can be defined where my swap will get created. As I tell, by default, it is with VM folder. Also, we have a choice. We can define the swap location on different data store. It could be a remote data store, or it could be a local data store available on each and every ESXi host. Normally, best practice recommendation where you will say this swap is created on the same data store where my VM folder is allocated. Okay, and prefer to keep into SSD drive, into flash drive, underline flash drive, so that a faster access could be happen for the memory pages. Right, so this is one of the memory overcommitment technology where our VMs required more than allocated VM. That case for the memory pages which is not currently being used for by the virtual machines being swapped into the underlying storage, and this underlying storage by default with your VM folder, but also we have a choice to define the swap location for the VMs in different data store other than where my VM folder has been created. Yes, now it's your turn. If you have some doubt, some question, ask me. I tried my best to describe this, but yes, if in case you have question, please let me know. Siva, Pramod, Parveen, we understand?
Whenever we create a virtual machine, by default, this file will be created.
Yeah, but this file size is dynamic always. Whenever swap is required, this file will increase. Whenever swap is not required too much, this will decrease. The max size can go with the swap file is maximum equals to your virtual machine memory, not beyond that. All right. For example, in this situation, it required 2 GB swap, but like after some time, memory consumption goes to 6 GB. Then automatically this 2 GB swap will be decompressed and it will come with a FivMB file only. Got it? So whenever it's required, it will increase. Whenever not, it will decrease. It is not a permanent size.
So is there any correlation like we enable swap in the Windows? It is a different thing and this is a different thing. There is no any correlation between.
Absolutely correct.
Okay.
Windows you will
So
define inside the operating system. That swap will create on local drive.
mm-hmm.
CPU drive. Okay.
Okay.
It will be identified by your operating system. Even in previous example, I have told you. Again, I am repeating. If I have allocated 8 GB, but at the moment it is require more than 8 GB, 2 GB. Due to some application I got that, or that time this 2 GB will be additional 2 GB will be placed into swap. Okay.
Okay, with the
It's a
memory
booster.
which is
I have some booster, like for example, somewhere you are running, some you want some extra water, glucose or something like that. That is available for you at the time of moment as and when you need it. Okay. But it will be
yeah,
taken back whenever it is not required to you. Okay.
how it's work in the background. I'm not able to understand.
What kind
Means
of
suppose
background?
that
Uh,
we have allocated 10 GB
hmm,
memory
hmm,
on first virtual machine.
hmm,
Anyhow application required 12 GB.
hmm.
So this virtual machine communicate with the ESXi host and with
Yeah,
the
that's what I
ESXi
told you in
host.
previous slide. There is a virtual machine VM monitoring layer between your VM kernel and virtual machine. That virtual machine monitoring layer will let you know your VM kernel. Now this VM is memory hungry, but whatever you have allocated, it's already being used. Okay. But also on host level, we have already defined a swap space. So whenever it will go beyond the allocated memory, the rest of the pages will be swift or will be transferred to your physical drive, the data store which you have defined for storing the swap files. Clear?
So we have to define swap level on the ESXi.
For each and every VM, swap file is already being defined. Yes, by default, your swap file location is the same data store where your VMs have been
Mm-hmm.
created. But if
Yes, yes, yes.
specifically you want to define the separate data store, you go on the host level and define the swap data store.
Okay, understood.
Okay.
So there is one layer on the ESXi host which helps to communicate to the virtual machine if virtual machine required
Yeah, that
more
is
than
virtual
the
machine monitoring allocated. Correct.
if virtual machine required more memory than allocated. So that layer communicate with the ESXi host and virtual machine and it will be located
Layer is
to
always
the
there.
swap file.
Virtual machine monitoring layer is always there. Okay.
Yeah, okay.
And the extra space, it will just trigger as a swap. Swap will get created under the date somewhere in underlying data store. All right.
Okay, okay.
So one more is
So
we have like 10 GB,
Hmm.
but the require we have 8 GB, but the requirement is only 6 GB. Even that time the
No,
swap file should be created.
your
no.
voice is not coming clear.
No, I can repeat Siva's question. Siva is asking if I allocated 8 GB and currently it's using 6 GB, that time swap will not use. That was a swap file. That would be swap file size only, FivMB. It will not use that. And how much maximum it can use? It can use maximum equal to the allocated virtual machine memory, not beyond that. All right, Siva?
Not beyond that means suppose that 10 GB is allocated. If virtual machine required more 2 GB memory,
Hmm.
so it will be provided Means
Your
that layer
swap
will provide.
size will be maximum equals to your memory size, not beyond that. If you have allocated 10 GB, swap can be maximum 10 GB, not beyond that. Okay.
Okay, okay.
So that time 10 plus 10, your VM can go with up to 20 GB of memory, right?
Okay, okay, understood, understood. Okay.
So memory over commitment, for memory over commitment, it's not only swapping. There is also number of technology being used by your ESXi is pretty much smart enough. Okay. So another method is economize use of physical memory pages. When we say economize, so it's known as transparent pages being shared. So being shared means, if like for an example, multiple VMs are using same memory pages, so it will share from the same memory. That's a kind of transparent page sharing. So that point of time, like for example, I am running 10 VDI, and under 10 VDI, the operating system have using the same kind of files and same kind of that time it will allocate from the same memory page. That's called transparent page sharing. So in that way, it can be more economize of memory. Deallocate memory from one VM to another. So deallocation means is, you understand that very well. But again, so as I from the day one, I'm telling memory allocation is always dynamic here. So what do you mean by deallocation? Let me take you the previous picture. Forget for now about the swap. Like for virtual machine, you have given 10 GB, 10 GB, 10 GB is allocated. Okay, 10 GB is not used actually. The time, and suppose I have 32 GB, or like for example 40 GB is my memory bank, underline physical memory. Okay, so this 10 GB is not always fixed. It means that if for an example right away it's using 5 GB, so it means that 5 GB buffer my host have. For time being it's using 8 GB, then it will give. All right, and again if this machine goes to 10 GB, after some time it come back to 6 GB, it will take 4 GB back. So this memory bank is always dynamic, and it's the ballooning. When we say ballooning, whenever you wants to take that, take that. But today, at the moment, if you don't use it, it will shrink the memory balloon. Like it using 10 GB for a moment, but later on it require 5 GB, so it will make a 5 GB of balloon for that. All right. So giving memory on the basis of utilization, and whenever on the virtual machine it's not required, take it back. Okay, so it's a kind of ballooning, up down, up down, up down. Compress memory. So memory compression tries to reclaim the some memory performance whenever memory contention is high. Host level SSD swapping, the example I was telling you, swap can be done on SSD level so that fast in and out pages. Page VM memory out of the disk. Using VM kernel swap space is the last resort of because of poor performance. So these are the VM kernel swap. So ESXi also have its swap space. Beside the swapping, it's giving to virtual machine memory. The previous example, ESXi also have its own swap space. So that's the last resort of giving the required memory to the virtual machines. So lot of technology is being used for the memory over commitment, that is between VMs and host. All right. And the features are, most of the features are by default enabled. You don't need to be worried too much about that. Okay. So a lot of intelligence being used by your ESXi host already. Okay. So now you can ask me questions, sir, like if my host have, beside hypervisor, my host have 32 GB of memory, what best practice you will recommend to allocate? Okay. So my recommendation and best practice is just allocate 1:1.25, means 125%. 125% of 32 will be 36. If I am not wrong. 4 6 नहीं, ये 40 GB हो जाएगा, राइट? तो 40 GB you can allocate, monitor that If you see the overall utilization is not going beyond 30% or 40%, then you can increase this ratio. Probably 1:1.30. When I say 1.30 is 1.25 is 25% more. 1.30 is 30% more. Okay, try to keep on increasing. Start from 25% more as compared to the available memory to allocate to virtual machine. See the overall utilization on monthly basis. If you feel that utilization is not going, and average utilization is not going more than 30%, 40%, then you can increase that ratio. It means that you can allocate more memory, or it means that you can provision some of the VMs in the same ratio. Got it? Can I take to this ratio 1:1.50? My answer is yes. That's not a problem. Even you can take is 1:2. That's not a problem. But the problems occur when you will actually see the utilization. Allocation is never a problem. Utilization is a factor. Correct? Even on 32 GB, you can assign 64 GB, even 256 GB. That's not a problem at all. But actually, what is your utilization? And utilization you can only observe after actually virtual machines will be deployed and after the consumption, a monthly graph, a monthly average consumption, right? Then only your decision factors will become. So that's why I say for the safer side, it started from more than available like 25%, like 32 GB I have considered beside hypervisor. Leave the hypervisor memory separate. Beside hypervisor, I feel 32 GB is available. Provision 25% more. Observe the monitoring. If it's fine, then go beyond that. Okay. You clear? Yes, no? Any answer? Are we good?
Sir, for me, it's
Yes.
a little bit confusing this one. So whatever you told this one, the
Hmm.
ratios.
You should shout, na? Ask. If you will not ask, I will not get now. Simple example. If one particular ESXi host, I am saying on this host, beside hypervisor memory is being, let us simple example. If I would say this host have 42 GB, out of 42 GB, 8 GB use my hypervisor. So how much I remaining now? 32 GB, correct? Now you have started to given this memory to the virtual machine. Okay. You are saying, sir, 8 GB, 8 GB, 8 GB, 8 GB. Can I go beyond that? Yes. Can I go beyond that? Answer is always yes. Provisioning is not a question mark here. Utilization is question mark. Okay. So what you would expect out of this 32 GB, how much should be utilized? You would say, sir, out of 32 GB, I would say ये 90% something or 85 पे मेरे को warning आ जाना चाहिए. There should be a warning on 85% and there should be an alert on 95%. Okay. In that case, you will say, sir, out of 32 GB, I would say up to 20 utilization, up to 27, 26 GB, I am okay. Okay. All right. Good so far. Yes, no.
Okay.
Okay. So now you say, sir, 8. I have provision too many. I have provision 48 GB. All right. Again, I am saying provisioning is not a matter. If my utilization is beyond less than 26 GB, my utilization is 22 GB. You are good. Not a problem. Okay. But if your utilization is touching somewhere, actual utilization is touching somewhere 26, 20 GB, you will start to getting the alert and warning. Okay. So that's why I say start from beginning provisioning of 25% more. So if I'll say 25% more is 40 GB. Provision 40 GB on initial phase and check the utilization. If you will say, sir, provisioning 42 GB, but my utilization is only, average utilization is 40% or something like that. So how much 40% of 40 GB? 16, correct? So after you given 40 GB, but your utilization is 16 GB, it means that still now you can provision more, because my warning or something will alert on 85 or something. ये alert और warning generate होगा 26, 27 पे जा करके. So then you are free to provision more also. Okay, you will keep on provisioning, but I have, end of the day, I have to see my actual utilization. As I said, from best practice point of view, we start from more 25%, monitor it, observe it. If you feel that's not more using, you have a choice to provision more machines, to allocate more memory. Still you feel 40%, 50%, provision more, allocate more. That's not it. Allocation is not ever a problem. Utilization is a problem. Okay. We good so now? Understood? अभी सिंपली अगर 32 GB है तो we will start from 40 GB provisioning. We will see the utilization. If my utilization is only 50% of this, it means that my utilization is only 20 GB. I don't have any problem. I can increase this ratio 1.25 to 1.30. Then you would say, sir, 1.30 is 48 GB. Out of 48 GB, still my utilization is 50%. I would say you are okay with this ratio, 1:130. So you go ahead and do that. Good.
In real time, how it works, sir? Same, it works, sir.
Huh?
In real time, same it as applicable, sir.
Yes, yes. Same is applicable. That's what I'm trying.
Okay, sir.
Applicable is anything, but I'm trying to tell you from best practice point of view, how you should use it. Correct? Initially, from the available memory, provision 25% more. Observe it for 15 days or a month. If you see, sir, my utilization is not going beyond this 30% all. Now you have a choice to increase more. Just increase that ratio. Okay. After increasing that, you feel, sir, now my utilization is approximately 50%. Now, if you are satisfied with 50%, don't increase that ratio. Don't increase means don't provision so much VMs. Stop there. Okay. So it's not only for one host. It's a calculation of overall cluster. Okay. So it helps you a lot when you are doing sizing for the customer. How many hosts you require for these VMs? Required this is the required virtual machine, required memory, average memory. So on that base, you have just provision that. So my graph should be, we feel good, 50% utilization to 70%. We always feel good this ratio. Okay. If this is less than 30% or something like that, then we say our cluster is under provision. What do you mean by under provision? Cluster have good, but not have enough VMs. If this go to 70% utilization or more than that, we say over provision. When we say over provision, it means that you need to increase the memory resources somewhere. Anytime there could be a memory crunch. Got it? So the best ratio being considered as somewhere between 50 to 70%. All right. Not only for memory, also for your CPU resource, also for your network and storage resource. We good, Parveen, Pramod? Any feedback? Yes, no?
So, sir, suppose that this ESXi host having like 48 GB of RAM.
Huh.
Okay. And 8 GB is used by ESXi host. Okay.
Huh.
So remaining is 40 GB. Okay.
Correct.
So now four virtual machine having 88 GB. Okay.
Huh.
And it is for all 8 virtual machine using 8 GB RAM means total 8 sorry, all virtual machine allocated 8 GB and they are using all total 8 GB. Okay. After onwards only 8 GB
How
is
many
left on
machines
the
you are
ESX.
considering?
Only
Four.
sorry.
How many machines you are assuming on the top of 40 GB?
40 GB. Okay, no. ESXi host having 48 GB and 8 GB totally
That
used
is
by
okay. That
is
is okay.
hmm,
I understood till
okay.
that level.
Okay.
Now
So I
you,
am considering four machine. Okay. My question
uh,
is little bit different.
keep continue. Start.
Okay. Okay. And we have created eight virtual machine on the ESXi host. Okay. And sorry, four. And all four having 8 GB.
Hmm.
How much?
32.
Okay, 32. Okay. And all these four virtual machine utilizing 8 GB memory. Okay, totally.
Okay.
Means each 8 GB.
Hmm.
Okay, fully utilized. Okay.
Okay.
So suppose that I will create one virtual machine like having 10 GB.
Hmm.
So it will be I have created one virtual machine with 10 GB. Okay.
Huh.
So if I will try to power on it, it will power on or not? Because there is some confusion in this question. Yes,
If during the boot time it immediately require 10 GB, it will not power on. But
okay,
only
and
for booting, if it's required 2 GB or 3 GB, it will power on.
okay,
But
understood.
this 10
Means
GB is allocated, right? Not the
hmm.
utilized immediately during the boot process.
So for
Right?
powering on this virtual machine, at least 10 GB should be required. Means there should be 10 GB on the ESXi host, right?
Absolutely right.
Okay. And what about the CPU?
With CPU we
If
will
we
talk. CPU will talk in CPU case. You clear on
okay,
this question?
yes, clear.
So wherever we feel resource crunch, out of 10, 9 issues related to memory, never CPU.
Mm-hmm.
Okay, because CPU have the vast in CPU has been virtualized in vast way as compared to memory. Okay.
Okay. So this is the interview question.
Yeah. So okay, Shiva, you clear on your doubt?
Yes, sir, cleared. But now Pramod asked one question that last one, the 10
Yeah,
GB.
yeah. Please,
The
yeah, please.
that was confused for me
Ah,
because you told that swap file will be created and it'll like manage to the memory. But
ah.
now you are
Ah.
saying no, we need like 10 GB to power on the machine.
नहीं
That
नहीं
was
हाँ
the confusion.
देखो नहीं
Siva, can you please speak a little bit louder because his voice is not coming clearly?
Now, are you able to now,
yes we
Pramod?
are नहीं where he's Parveen actually who asked this
Sorry,
question.
Praveen.
Yes,
Uh,
yes. Actually,
no,
actually
Praveen,
not
you
able
told
to.
that lost the 10 GB, right?
Your voice is cracking.
नहीं
So
नहीं Parveen,
sorry.
your voice is good for me. I
Yeah.
will repeat on his behalf, no problem. His question is, in
Hmm.
last moment you ask about this 10 GB, right?
Yes,
Right.
yes, yes.
It's power on or not? अगर 40
Hmm.
GB, my memory bank is available 40 GB, 8 GB, 8
Hmm.
GB, 8 GB, 8 GB is here, okay? And they are
Hmm.
fully utilized.
Yes,
Swap
yes,
we are
yes.
not taking in this example in picture. Shiva, for your exam, for your note, for your question,
Yes.
to answer your question, we are not considering swap. We are
Oh,
considering the actual consumption of this memory,
okay.
32. Okay. So out of it, it's asking whether I will be turned on 8 GB, 10 GB or not. My answer is, if during the boot time only it require less than 10 GB, it will be turned on. But if it's required 10 GB immediately, it will not.
Okay.
Okay. But yes, if my swap comes in picture, then it will be resolved more. As I told, ESXi host, this I am taking the last condition of that. If we'll talk, there is lot of terminologies being used. Okay, these all terminologies being used. Don't worry about that. And also, this is just a situation. At the time, all VMs cannot keep on utilizing. It's an always dynamic.
Okay.
Okay. It's for few seconds only. You will not feel even that situation in a real environment. All right. But yes, as an underline, they will use swap, they will use compression, they will use transparent page sharing. Okay, so it can go, but as a last point, if we'll say nothing, anywhere memory is not available, what will happen in that case? What I told you, during the boot process, if my last resort have available that memory, okay, if not, then it will not turn on.
It will not power on. Okay.
Yeah.
Okay. Okay.
So can we consider the second example, like here for the swiping? Suppose that
Swapping तो
we can
होगा
take.
यार, वो तो that's a default nature. Even when you taking this example, 8 GB, 8 GB is being used, that is allocated. Even it will go beyond that 8 GB, that swap will start. Till 8 GB, SXI is capable to give the memory, right? Because he have it in memory bank.
Swiping file is used in data store, right?
Swap it will only use when host will not have the memory to provide allocation. In your example, your host was having sufficient memory that time, right? You got my logic or not?
Yes.
Because out of 40 you have given 32, so still RAM is there. There is no use of no use case of swap. Swap use case only come whenever my ESXi memory, actual memory is not capable to provide RAM to the virtual machine. Why we took the swap?
Virtual memory is not available
No, physical
on the
memory
ESX
is
side.
not available on my ESXi. Then only it will go for swap. Correct?
Yes.
But in
So
your
some of the.
example, there was RAM available. That's why swap did not come in picture. Don't mash up with multiple things. Okay. Now it is we good now. We good now.
Yes, yes.
All right.
Yes, sir.
So these are different technologies, but use one like as and when uses, correct? Not immediately on. All right.
The concept is same like Windows. Means suppose that we have like
विंडोज में लोकली ओएस पे बनता है आपका स्वैप,
yes,
इधर
yes,
आउटसाइड
yes.
राइट.
Okay, okay. Let's आउटसाइड द डेटा, मतलब डेटा स्टोर के अंदर ही बनेगा ना सर? अगर
राइट,
मैंने 10 फाइल ओपन कर
एब्सोल्युटली
लिया, ठीक है, और 10 फाइल अभी यूज नहीं हो रही है, उसके बाद वो 10 फाइल खोल के रखी है, ठीक है, ऑल टोटल,
करेक्ट.
और मैंने 11वीं फाइल खोल दी, तो 10 फाइल में से कुछ फाइल को वो स्वैप फाइल में
उसका
डेटा स्टोर में
मेमोरी एलोकेशन जो है वो डेटा स्टोर पे मूव कर देगा. करेक्ट.
वो मैं वहां
बट
कर देगा, फिर
बिसाइड दिस वो
उसको।
लोकली सी ड्राइव में जो ओएस लेवल आप बात कर रहे हैं स्वैप का, वो लोकल भी बनाएगा. करेक्ट. क्योंकि वो ओएस का प्रॉपर्टी है, दैट्स नॉट योर हाइपरवाइजर प्रॉपर्टी. करेक्ट. वो इन दैट केस आपका दोनों स्वैप यूज होगा. यू विल यूज बोथ द स्वैप्स इन दैट केस, द ओएस वन आल्सो, दैट इज द ऑपरेटिंग सिस्टम फीचर, एंड द हाइपरवाइजर लेवल एज वेल. That's your hypervisor level feature. Okay.
Okay.
So he will try to cater the memory locally first, but if it is not possible, then it will come to outside.
Okay, okay.
So now configuring multi-core VMs. So on CPU, we talk a lot. If you will go back the initial history, how the CPU allocated being happened. Okay, let me repeat the same thing again in brief. If you have any question, you ask me. So any of the host can have physical socket, and under this socket there can be multiple cores. Okay. So leave this host for now. I'm just taking for reference. So if I will say 2 socket with quad core, it means that now I have total 8 core. 8 core means your host will indicate them as an CPU core, logical CPU. Okay. And totally on 8 core, how many vCPU we can create? Again for VM have a feature of virtual socket and virtual core. If on particular VM I would say 2 virtual socket with 2 virtual core, then there would be total 4 vCPU. Correct? If I'll ask you an
Please,
answer.
so can you please repeat once again from starting here? Code.
Where?
When you start. Yes. Discard on this. Yes, yes.
This is my ESXi host. Okay.
Okay.
These have 2 sockets. Each socket have 4 core. Then there would be total 8 CPU or 8 core, I could say. Okay. If I am
Okay.
going to create a virtual machine have virtual socket, virtual core, like 2 virtual socket, 2 virtual core, totally 4 vCPU. Same way I can create another virtual machine also, and they can be occupy the cores from the underline. But now question is, sir, if I will take one logical core, how many vCPU I can provision on it? One core pe you can provision up to 32 vCPU, even on a single core. Okay. So simply in this example, if I will say
32
maximum
multiplied.
value 32, 256 vCPU I can go this, but ideally not. This ratio can be taken 1:4, 1:6, 1:8, like the way. Okay. So if I'll say 1:8, it means that on the top of it, you are able to provision totally 64 vCPU. Okay. So again, same example. Initially, you take some ratio. Keep monitoring your CPU utilization. If it's go beyond, increase less it, reduce it. And if we will go lesser in use, increase it. Got it? Let us suppose you take 1:6 example. So 1:6 may how much you are provisioning in this example? 48 CPU, correct? 8 6 ja 48. But you see after 1 month, sir, my utilization is 20-30% only. Can I increase this ratio? Yes, why not? Increase means increase this ratio, this value. Okay. Then you just try to do it as 1:8, means provision 64. Or if you'll say in this example, sir, my CPU is utilizing high, I don't want this ratio, I'm not getting CPU performance, decrease it. Decrease means is rate it 1:4. This is the decrease. So how you will decrease it? Either delete some VM or migrate the VMs to another host.
Okay, understood.
All right. So that's
Yes.
the way of sizing your CPU. On normal VDI general purpose workload, we typically take 1:6, and if it is a kind of database or something like that, we take this ratio 1:4. But again, the asterisk is here. Keep on monitoring, check it, and what is the feasibility of increasing and decreasing. That's all depend on again the utilization. Okay. I tried to explain you in very short because I explained this concept multiple times. Even if you will see your initial recording, there is also available. Then what is hyperthreading? If we will enable CPU as an hyperthreading, so hyperthreading simple is it will double of your logical CPU. It will present the, like for example on ESXi host, we have for this example, we have, this is my socket. Under this socket earlier, there was 2 core, 2 logical CPU. But if we will enable hyperthreading, it will double my core. It will double my core. So now my core will be, my logical CPU will be 4. So we have seen in some of the applications on the VM itself, they required more than actual cores. Like those are, they required multiple threads CPU to run. That's called hyperthreading. So in that case, if we'll enable hyperthreading on underlying host, then we can assign more vCPU cores here to present the more threads. When Swiss thread means is, like for example, one application required 2 threads. It means that will run 2 threads and that required 2 separate cores. Okay. And to fulfill those number of many cores, on application level, we enable the hyperthreading. So hyperthreading will present my CPU logical core by numbering it double, so that we can provision the more vCPUs on virtual machine. Okay, some of the application required more vCPUs, parallel CPU. Like there is one application that is being designed in that way that require at least four threads run in a way simultaneously. So it means that required the 4 vCPU to run that application. So that at that point of time, we need more number of vCPUs as compared to the traditional number of vCPUs. So to allocate them more number of vCPU threads and all, we have to enable hyperthreading on BIOS level in my ESXi host. Okay. All right. Clear? Yes, no? Expecting any yes? Parveen,
Yes, sir.
mode. We are good?
Yes, sir. Yes.
All right. So single CPU load balancing, I already give you a lot of examples of it. How do we do a CPU hyper-threading dual core, dual socket? It means that my logical, my under core will be multiplied by 2. Okay, one logical CPU will present as 2 logical CPU. Simply then I can create more vCPUs as compared to non-hyperthreading enable CPU on the BIOS, on the ESXi host, right? Yeah, so these are the concept with respect to balancing your CPU and memory. Then resource control, that's again some tricky and logical mathematics here. So I'll continue it tomorrow. Give some rest to your brain. Hear the videos what we have discussed today. But again, if you have some questions, you let me know. Okay. Don't worry. Ask the question, clear your doubt, because these are the things will helping you near in future when you will be designing any solution for the customer. Nobody teach you on that deep level and give you the concept how it's will be done, because these all things will be helping you whenever near in future you will work kind of solution architect. You will be sizing something for a customer environment. These all factors comes in picture at that point of time. All right. Okay, guys, that's it from my side for today. Again, still, if you have some doubt and question, please feel free to ask. And tomorrow,
Sir,
resource control.
like,
Yes.
if possible, please share the PDF also. Like, it will be.
A PDF though not possible because yeah, these are restricted one. But yeah, these all are
Okay.
covering in your this training slides. Okay. What I can do for you, like the way which we are covering, a day I will make a recording only for PPT. Okay. You get my point?
Okay, sir.
What for the whole PPTs. Then anytime you can pause the video and you can look up. Get my point?
Sure, sir. Because
Yeah.
this PDF, there is some important informations if in below. So
Yeah,
I
no
thought.
issues, no issues. A day I will just make a video, only just click, 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 click. That's it. That day don't ask me any question, okay? All right.
Sure, sir.
So then you can walk through with this. All right, guys. See you tomorrow then at same time. Enjoy your day, enjoy your learning. And most probably we'll try to finish it next in this week itself. But yeah, definitely we'll keep one more week for recap purpose. And if you have some question and answer, we'll try to cover that also. Okay. Or if you are interested to see some of the lab is missing and you feel, sir, I want to do it from my end, my hands. So that will be available. All right. So I'll give you 3-4 days for recovery purpose. Let me just stop the recording first.